Let's find magic ghost numbers in Platonic solids. This is one solid that I found last night. The magic ghost number, the inner and outer magic ghost numbers. The red in the center, the purple around the edges of the inner octahedron, and that's supposed to be red. The 108s on the corners of the outer octahedron. A cube has 6 faces. That's my magic ghost number cube. Magic ghost number cubes require 6 numbers in each cubic octahedron, 3 primary, 3 secondary numbers to give the outer ghost numbers. These octahedrans right here, this octahedron right here, and all the other octahedrans. Magic ghost number octahedron requires 8 numbers around each vertex, 4 primary and 4 secondary numbers to give the outer ghost numbers. The primaries are the light blue, which is in the back, and the dark blue, which is in the front of the inner and outer octahedron. And then the secondary numbers are the orange in the front and the yellow in the back of the outer octahedron. And these are the numbers that you add together. The 4 numbers right here of the secondary, and the 4 numbers right here of the primary to give this number, the same as on this side, the same yellow and orange, and the same 4 blue and dark blue to give 48, and the same as on these other sides. This is the first one I've ever found, the first true 3-way proof of the reason for them being there. First, it's 3 times like this is 3 times. This is the inverse of a cube. This octahedron is 3 times the central ghost number. It's also the diagonals, these 4 diagonals instead of 1, 2, 3. These 3 diagonals instead of 4, and these outer numbers, the outer ghost numbers. All 3 of these are proof that these are the ghost numbers. And I've already found the tetrahedron. That all that is a magic ghost number cube, magic ghost number square, flattened out. If you see 1, 3, 2, and 4, there's no commutative ability because they're not across from each other. They're diagonal to each other, so there's no commutative ability. But if you flatten it out, you get a magic ghost number square. And so in a way I found that one. And now what I'm searching for is the dodecahedron and the icosahedron. One has 12 faces, and I suspect it will have produced 12 outer ghost numbers at its corners. The icosahedron has 20 faces, but will produce 12 outer ghost numbers at its corners. And this is the hardest to produce because as you go up with faces and edges and corners, more numbers are being produced. So I have to separate them. I separated the central ghost number from the primary numbers that make them up on each object, and from their secondary ghost numbers that are added from the primary numbers, from the inner shapes, and also the outer shapes. And it's really complex. More numbers to crunch. A giant array of numbers that I haven't solved yet. But I've solved my first ever higher polyhedra with 3 proofs of its being there, the ghost numbers being there. And I've already did the cube for a long time. That's my first realization of the ghost numbers. And I've already done the tetrahedron, which is a flattened out magic ghost number square. Now I'm working on the dodecahedron and the icosahedron. And they're harder to crunch. The numbers are harder to make out which ones will become the central, or which ones will become the diagonal numbers, and which ones will become the outer number off, or whatever they are, spaces that make up the outer results.